Okay, Siddhi, you may proceed.
Thank you, sir. Good evening, everyone. Welcome to the Centenary Celebration of Department of Mechanical Engineering, IIEST Shibpur. I am Siddhi Suman, a third year undergraduate student of this institute and host for this evening. Today, we all are here for the 35th lecture under the Centenary Lecture series, which is to be delivered by our honorable alumnus, Dr. Pranab Saha, on the topic Acoustics in Our Lives, emphasis on the acoustical materials to reduce vehicle noise from the past to the future. This session will be chaired by Dr. Shudip Ghosh, who is Associate Professor and Head of Department of Mechanical Engineering at IIST Shibpur. I would like to invite Dr. Shudip Ghosh, sir, for the further continuation of the program. Sir. Sir, you are muted, sir.
Yeah. Am I audible?
Yes, sir.
Yeah. Thank you, Siddhi. Good evening and welcome. Today is the 35th session of Centenary Lecture series of this department. As you all know, we have started this series 9 months back in December 2021. And we have heard a number of experts, both from academia and industry, as well as R&D organizations. Today we'll be hearing Dr. Pranab Saha, another expert in acoustics, particularly in vehicle acoustics and noise control. Dr. Saha has graduated from this department in 1972. Thereafter, he has moved to USA and joined University of MS, and then he moved to Georgia Tech for his PhD in 1975. So since his early research days, he has been working on noise and vibration control. So he's having more than 40 years of experience. He is also an entrepreneur, and he co-founded Colano and Saha Engineers, I believe, with Dr. Colano. So as principal or consultant of that organization, he leads a dedicated team working on automotive systems. Dr. Saha has directly participated in numerous advanced noise control engineering programs and training programs of at different forums. Dr. Saha is an active member of SA International, SA USA, ASME, INC USA, and many other organizations. Dr. Shah assisted in the development of several SAE standards on acoustics and SAE document how to write an SAE technical paper. He is the lead faculty member of SAE Vehicle Interior Noise Academy and an associate editor for the SAE International Journal of Vehicle Dynamics, Stability, and NVH. In 2021, Dr. Shah received the SAE International Medal of Honor, the SAE International Ralph Hillquist NVH Lifetime Achievement Award. SAE published his book on acoustic materials, Solving the Challenge of Vehicle Noise. Dr. Saha is INC USA Board Certified Member and INC USA Director, a fellow member of SAE International and ESD, and has been named an SAE Master Instructor. So I have the privilege of inviting Dr. Saha for today's session. I leave it to Dr. Saha for starting from here. Today he will be speaking on acoustics in our lives, emphasis on acoustical materials to reduce vehicle noise from the past to the future. Dr. Saha, please. The floor is yours.
So kindly unmute yourself, sir.
It's still muted. Yes.
See the screen.
Yeah.
Are we there?
No, the screen is still not visible.
Still not there. All right. I did optimize the motion and video at the screen.
Yeah. It's coming.
Yes.
Now, finally,
Yes.
it does take me a while. I'm a blackboard and a white chalk guy. That's what I learned from B College. And even before that. And I still maintain that. Thank you. Thank you, Professor Ghosh. Good morning and good evening to all of you, depending on which time zone you are in today. I'm honored to be here, although it's virtual. I graduated from B College in 1972. I think in the 72 batch, our exam did not take place in May or June of 1973. You can figure out what may have happened in those 1 years, why we were delayed by so much. Then I visited one more time, I believe in August, to have a proof, although our final results was not published, that I will pass my undergraduate from BE College so I can get admission in some other places for masters. After that, in the last 49 years or so, I have visited the campus of BE College twice, but they were both during the holidays, and therefore I couldn't see anybody except the buildings and some old memories. I want to thank my brother, Dr. Pranab Saha, for asking me if I would be interested to participate and talk in this Centenary Lecture series. So thank you very much. After that, I communicated with Dr. Sarkar and Professor Ghosh, Professor Paul, and here I am today. The theme of today's talk is acoustics in our lives, with some emphasis on acoustical materials with vehicles and what's happening. And I really like that because we all like vehicles. But the presentation I've divided into 3 parts. The first part is a little bit about acoustics in general that we see in our daily lives. And then we will talk about vehicles and sound package materials, how we quiet vehicles from the past to the present, and then what is happening in the vehicle industry in the future. Acoustics has different meaning to different people. To someone, it is a part of music or musical instrumentation. And to somebody else, it's the ambiance, it's the environment. The place is so nice, so quiet, so pleasant. Acoustics in that sense is something that we enjoy, that we like. On the other hand, there is something called noise. Noise is something that we would like to avoid. So if the tree falls in the forest and nobody is there, do we have noise or do we have sound? I will let the physicists worry about that. We, the engineers, we have more practical things to do. We will go and try to address those things today. In the next 4 slides, I'm going to talk about some different areas of acoustics. One would be plant and industrial noise. The next one would be community noise. The third one would be architectural acoustics. And the fourth one would be binaural measurements. So the very first one that you see here is the plant and the industrial noise. In a big manufacturing plants, they are making fasteners. they're making washers, they're making nuts and bolts. It comes and drops in these bolts. As it drops, it makes noise. So people who are working there, they're exposed to this excessive noise. The more noise you get exposed to, eventually you're going to lose your hearing. Therefore, the plant manufacturers, the plant owners, the management, they try to do something to reduce the noise. Sometimes that noise is also coming from this power generator noise. It is housed in a building, but that noise escapes from the building, goes outside to the community. This is a baghouse blower. The noise is started from the plant to the baghouse blower going to the community. So we have to worry about that. This is the mechanical vibration isolation. Sometimes when we have this noise, there is structure-borne excitation. So we need to isolate that. We will talk a little bit later when I come to my favorite topic on vehicles about different types of noises. This is an heating, ventilation, air conditioning, duct work, which otherwise would generate noise in an acoustic lab where you can't accept that because you want to make measurements of your product in a quiet environment. So these are some different examples or applications of plant or industrial noise that we have seen, we see every day in one shape or the other. Some of that noise now comes to the community. This is, I'm making measurements in the property line of the community. This is the transportation noise on these freeways, highways, byways, all these cars and trucks and other transportation systems that are going by, they're generating noise, and that noise eventually emits and comes to the residential area. To block that noise, sometimes we have walls. These walls separate the freeways from the residential areas. We can do modeling. In today's technology, we would like to do analysis, model, predict. And these models allow us, this is my noise source. This is a pillar or a block or a building, and how does the sound then propagates or radiates to the rest of the neighborhood? If I can determine that, that'll be very helpful. Sometimes when we make these measurements, we want to look at the noise level with time history. So this particular bottom left slide is showing you the x-axis, the horizontal axis is the time, the vertical axis is the sound level in dBA. It shows you different events that are taking place for how long those events are taking place. These are all important if we want to reduce the noise so that in the community, people would be in a little bit more pleasant situation. This one is previous slide. This particular, the bottom right picture was trying to show, make noise measurements of the product in the community. Architectural acoustics. We like to enjoy music. Obviously, the artist is famous, no problem. But the auditorium has a lot to do with it. It's not just the loudspeakers and the microphones. It's the room itself. So these are the seats that where people are going to be sitting, and then somewhere here is the stage where the musicians are going to perform from. We can do ray acoustic analysis. These are the seats. This is the performer. The sound goes up, reflects back, comes to the people who are sitting and enjoying the program. we can determine these things, how much of the sound coming from the speaker or the artist is going to reflect back at different locations. Based on that, we may have to add additional diffusers. As you can see, so the sound is more even in that space, opposed to in the very first slide on the top right, which are very discrete sound rays coming. At the end of the day, I would like the entire auditorium to be filled with the sound that we would like to enjoy, the music that we would like to enjoy and appreciate. So this is what it looks like at the end of the day, where you see all of these surfaces. These are all diffusers or reflectors. They have been specifically designed and placed so that the sound coming from the musician, coming from the loudspeakers, can reflect off and properly disperse where the people are sitting, the audiences are. Now I want to talk a little bit about binaural work. Binaural means the two ears that we have. This is very important because if we can simulate to an artificial head the human hearing mechanism in terms of the special separation between the left ear and the right ear and the directionality, then I don't have to have myself always listening to that sound. I can use an artificial head which will have instrumentation, which will have microphones on the outer ears of both ears, and I can record that signal and process it later to understand how do we really hear. Normally, all sounds are measured using a microphone. A microphone measures a scalar quantity, just the magnitude. It cannot give me any direction. But the binaural head, it can be simulated. So using the two microphones and the spatial distribution of how we hear, all those algorithms, it can not only give you the magnitude, it can give you the direction where the sound is coming from. If I take this a little bit more advanced, this is another mannequin where sound comes through the mouth because I have passed on signal through its brain and the sound is coming through the mouth. And then there is a loudspeaker here. There's a microphone here. The microphone picks up that signal and then it goes through various algorithms to determine what is the clarity of that sound that came out from somebody's mouth in a given environment. Some of you may have heard a term called articulation index. Articulation index means how well can I articulate in a given environment. If I go to a restaurant, everybody is talking. Even though somebody is sitting within a meter away from me, I cannot speak and the person cannot hear me very well because the clarity of the sound in that environment is not very good. So in architectural acoustics, in vehicle acoustics, this articulation is very important. And that's what one of these things can do. Nowadays, we all have iPhones, we have cell phones, we have modern phones. So we want to know. We don't want to say, can you hear me? Can you hear me? We want to be definitive that we can hear everybody very well. And this is a device that you can see on the head that is actually a rest so that this cell phone here is placed properly. It putting the right pressure on the ear. Normally, the way we will be holding the cell phone to be able to communicate with someone else. And then We send the signal through the mouth. The cell phone picks up that signal, and then we can analyze that data to understand the clarity of the sound. Depending on how much force I put in on my ear on the cell phone, they can be all simulated by this big gadget that you see on the head of this mannequin. Okay. The next thing we are going to talk a little bit is how do we get from there to here? Now we are getting more into the vehicles. Building a car, it has to do with designing the car, development, and its execution. Understanding the noise problem, if you're going to worry about acoustics in the car. We need to know the frequency contents. We need to know the level. We need to know at what environment am I putting these materials. We listen to the car both subjectively and objectively. We do it subjectively because we want to like the car. We want to understand something called the sound quality of that vehicle. We want to make objective measurements because we need something concrete which we can analyze, which we can rely on to make sure I do the job correctly. Today, my mood is bad. Subjectively, I think it's a noisy vehicle. Tomorrow, I'm very calm. I'm in good shape, feeling very well. The same vehicle that I heard yesterday and I complained the noise was too much, today I think it's acceptable. So that's the way the subjective thing works. We cannot rely on that 100%. We need to have objective measurements. We need to be able to analyze and predict information. In the vehicle construction, there are even today two types of vehicle constructions. One is called a full frame. When I say a full frame, that means you have a chassis. The engine is sitting on top of the chassis, and the body actually is installed on top of that chassis, and the body is mounted to the chassis by something called body mounts. Body mounts acoustically is nothing but isolators. The chassis is very hot. That means it has lots of energy because the tire, the wheels is driven on roads, on bumpy, rough roads. So all that vibration energy gets into through the tire to the chassis, but the body is isolated from the chassis by using body mounts so that vibration doesn't go through. The only thing that goes through would be the noise of the internal combustion engine. Or if we have electric motors, the noise of the electric motor. So the noise what we have is airborne noise. The solution for airborne noise is different than if I had vibration issues as well. Today we have unibody construction vehicles where the chassis is gone. That is necessary for the safety of the vehicle, not necessarily for acoustics. The safety is more important than acoustics on any given day, because after all, we're not going to lose our hearing from the noise in vehicles. So we have unibody construction vehicles, and therefore now the body panels, it actually feels the vibration directly. And therefore, we need to reduce that vibration. Because I don't have a chassis, I'm not going to be able to use an isolator. In order to reduce the vibration on the body panels, I need to use viscoelastic materials. I need to use damping materials. That noise or that vibration is called the structure-borne noise issues. The damping materials were not used in vehicles until the late 1970s, because around that time we started building unibody construction vehicles. So although viscoelastic materials to an acoustician was well known and had been well used all this time, but in vehicles, it's a new product. If we now look at the vehicle noise sources, there are propulsion-related noise. That means the moment I start the engine of one kind or the other, I have certain amount of sound. And then when I operate that vehicle, I want to go from place A to place B. I have additional noises on that. For internal combustion engines, which we fondly called ICE, we have the propulsion-related noises are engine noise, the transmission noise. The transmission is nothing but a whole bunch of gearboxes, gears. Then we have cooling fan noise, we have air intake noise, we have exhaust noise. We're going to talk about electric vehicles. We have electric motor noise. We have that gearbox noise from the electric motor, or it's going to the tires, the wheels. And then we have inverter noise and other things. The moment I'm driving the vehicle, in addition to this propulsion-related noise, I have road noise, I have tire noise, I have wind noise, I have brake noise. So when you drive or ride a vehicle, even though you are riding on the same road surface, some vehicles you don't like the noise of that because you hear too much of wind noise, too much of propulsion noise, or too much of wind noise. Some vehicles you like because those noises are all addressed properly. It's very smooth, it's more balanced, and things like that. If you look at an internal combustion engine, the primary noise source is the circled one here, is the internal combustion engine itself, and then the exhaust noise that you have. Then you have wind noise as you are driving the vehicle. You have tire thump as you are driving the vehicle. And you have many other different types of noises. Inside the vehicle, you may have air conditioning, or where you have, like here, we have to have heaters for sure because it gets very cold. So all those noises are there also for our pleasantness that we would like to have. But the primary noises that we are talking about is the propulsion related noise and the vehicle transportation related noise. In order to solve this thing properly, we need to understand at what frequency ranges do we have these noises. So for an internal combustion engine, there's an induction noise. The induction noise is related to the number of cylinders, the RPM, and that frequency range is somewhere from 50 hertz to about 200 hertz or so. At those frequencies, it is very difficult to solve the noise problem using sound package materials. So we will see if there are other ways to address those things, and some acoustics engineers will work on that. But then I drive my car. Sometimes I drive on a smooth road. Sometimes I drive on a coarse road. Sometimes there are loose gravels. and they all generate noise at lower frequencies, below 500 hertz or below 1000 hertz. Then I have the engine or accessory noise. That noise is from 400 to 4000 hertz. The tire noise, I'm driving my vehicle at 60 kilometers per hour or 50 kilometers per hour on a smooth road, and I hear this tire noise. That's around 800 to 2000 hertz. Then now I'm in the freeway. I'm on a smooth road. I can drive at 100 kilometers per hour, and I can hear the wind noise. That's the level of the noise is not that high, but the frequency range of the noise is at a frequency that I can tell the difference. It's 2000 hertz and above. An acoustics engineer has to know all of these things, at what frequency ranges these problems are, where the sound is coming from, so that they can have the right type of solutions to solve the problem. Today, there are electric vehicles. Tomorrow, there'll be more electric vehicles. And after some time, maybe there will be all electric vehicles. Electric vehicles have sound also. The sound is different. And I will talk a little bit more about it later. Right now, I just wanted to mention the electric motor itself makes noise at different frequencies that we were not used to hearing before. Then it has inverters to change the battery voltage to be able to run the electric motor. That inverter makes noise. We have gearboxes. The transmission itself makes noise. So there are noises in electric vehicles. In addition to that, as I'm going from place A to place B, all that coarse road noise, the tire noise, wind noise that I had before, they are also present in the electric vehicle, even more so now because the internal combustion engine's noise was masking some of that road noise, some of that wind noise. So just because I have electric vehicle doesn't mean that I don't have any noise. I still have noise of a different level, but at different frequency ranges that I was not used to hearing before. So for me to solve all these problems, I have to first acquire the data. People have been building cars for over 100 years, and people have been working on having quieter cars for at least 50, 60, 70 years. So I'm going to take you through some of the technologies that we had before and what we have today. We want to acquire the data. In the early days, we did not have battery operated recording devices. So we had to plug it in and have 220 volts or 120 volts, whatever the regular power supply is. And we used tape recorders. When I talk, when you hear sound from a very low level to a very high level. And that dynamic range could be about 100 dB or so. Those tape recorders that we had used before, reel-to-reel tape recorders. Some of you students, you may not even know what a tape recorder is. So that reel-to-reel tape recorder has a dynamic range of about 30 or 40 dB. Okay? How are you going to capture the vehicle, the noise of the vehicle that can range from a very low level to a very high level with a dynamic range of 90 dB or so? Those becomes very challenging, but we did it. We did it one way or the other. So here you see a reel-to-reel tape recorder, put it in the vehicle. At home, it's not a problem. I can plug it in to the electric current. But over in the car, what am I going to do? I have to have an inverter. This inverter is going to transfer the DC voltage of 12 volt to operate that to 120 or 220 volts. Okay. That's fine. How am I going to get that current? So I'm not going to have a mile-long cord to run this vehicle. You may have never seen this picture before. This is a very interesting picture. This is the vehicle whose noise we are going to measure. This is a trailing vehicle following this first vehicle, where we have all that tape recorder, the inverter, everything else. This makes the noise. So this trailing vehicle is making the noise. I don't know if you can see some dotted line on the top. That is actually a cable that's connected between the tape recorder to this front vehicle, where I have the microphone to make measurements. If you see the road surfaces carefully, this road surface is not the same as that road surface. These two cars are off by a certain amount. So you really have to have well-trained operators. So if this vehicle, the front vehicle, the measurement vehicle is operated at 100 kilometers per hour, this thing is also operated at 100 kilometers per hour, so that there is no other issues. That's the way we used to make measurements not too long ago, even in the 1950s or so. We tape record the data, then we bring it back to the lab. So now we can listen to that measurement. Here we are playing back that tape recorded data. People are listening through their headphones. And in this case, I'm playing back the data by using loudspeakers, and people sitting here are listening to the sound. Think about it. If I'm listening this way, that means the sound is generated through the loudspeaker. I'm in a room. If in that room there are other noises, would I be able to really judge the sound? The answer is no. So this room have to be designed properly, so the sound in that room is kind of uniform, kind of quiet. So acoustically designed room. Again, this room has nothing to do with the vehicle measurement that I'm making. But if this room is not acoustically designed properly, I will not be able to listen to the sound, appreciate that, and enjoy the vehicle noise. A room like that also sometimes are designed to test vehicles indoors. In today's technology, we have much more sophisticated equipment. These are all battery operated equipment. And I have this artificial head, the binaural head, that I can connect together. And then I can drive the vehicle on the test track, make measurements, come back and analyze the data or listen to the sound. On-road measurements are fine. Everybody makes on-road measurements because that's where we are going to drive the vehicle. In India, you have NAVTRAP, you have a wide, proving ground where all the car company people, they may come, or their suppliers may come and make measurements. But there's also chassis roll dynamometers. The chassis roll dynamometers are large wheels in a building where you put the vehicle, the tires are on top of those wheels. As the wheels are in motion, the tires will be running. Your vehicle is in neutral. So the vehicle is not literally going from place A to place B, but the tires are rotating. And as the tires are rotating, the engine, the RPM is changing, the speed is changing. You are hearing noise. You are making those measurements. This was one of the first chassis roll dynamometers built by the OEM, which is an open door or outdoor environment. Because usually you put this thing in a room which is called hemi-anechoic room. Hemi means half, ane means no, coic means reflection. That means in a room where there will be no reflection half of the space, because that way I can simulate outdoor conditions. In today's technology, you're going to have this hemi-anechoic room, and you're going to have this truck, and you're going to make these measurements in the lab. Sound package treatments and parts. Depending on sound, we may have absorption treatment. Absorption is a product that receives the sound energy, dissipates the sound energy within the material, and doesn't allow anything to reflect back. Then we may have barrier materials. Barrier materials are installed between the source and the receiver so that it can block the sound. To give you an example, a door is a good barrier, and the carpet or the cushions that we have, those are good absorbers. We use that for airborne noise. For structure-borne noise, we may have isolators that I talked before, or we may have damping treatments that I have also mentioned before for an unibody construction vehicle. And these are all many different types of parts that we have in a vehicle. Some of them are cosmetic parts, but cosmetic because you see it, but it has another function, which is acoustics. For example, this is a headliner. When you sit in the car, you look up, you see the headliner. So the headliner manufacturer puts a lot of effort to make sure it looks right. But it can also provide a lot of acoustics in terms of absorption. Between the engine compartment and the vehicle interior, we have something called a dash liner. Some people may call it a dash mat or a dash insulator. On the left-hand side, this is the dash insulator, which is based on a barrier decoupler system. All what it means for our purposes today, it blocks the sound. On the right-hand side, it is a fibrous material. It's a dissipative system. Dissipative system means it dissipates the sound energy. It works on its absorption properties, but it can also, by the process of dissipation, reduce the noise as sound goes through the material to the other side. The advantage of a dissipative system is a lighter weight than a barrier decoupler system. That goes back to the same things that Pankaj Mallik at one time talked about in composites and other things, that we are trying to reduce the weight in vehicles. This is the carpet. The carpet is something that you see inside the vehicle. So this is a cosmetic part, but the carpet liners can absorb sound, reduce the sound. If you remove the carpet and or rotate the carpet on the other side, you're going to see this decoupling materials or absorption materials that are there for acoustics. I want to talk about those decoupling materials that I showed you here. This is called carpet underlayment. Typically in a house, underneath the carpet, you have foam cushion materials so that you don't, when you press on it, you don't feel the hard surfaces. You feel some cushion that gives you some comfort. And this is called carpet underlayment. At one time in vehicles, we used to use jute as a carpet underlayment material. It used to come from India. It used to come from Bangladesh or East Bengal at that point, and then possibly Bangladesh. But then there is cyclone, there's flood. This crop gets affected. its transportation gets affected. The car companies in the Western world, they cannot rely on that schedule. Therefore, they started looking into other options. They started looking into cotton fibers. In North America, in the southern states, we have cotton trees, we have cotton fibers. We can grow that. In Europe, they used to work with foam. So one of the problems of this needle cotton fiber is when you make the part and stack one top of the other, and 50 or 60 of these floor carpets, you are stacking one top of the other. The bottom 10 or 20, they get crushed. These fiber pads, they don't maintain their thickness anymore. They get squeezed. When you did the design of that vehicle in the early stage, you designed such that underneath the carpet, there will be so much of room so that the carpet will fit there properly. If that room was 15 millimeters, and then in transportation, in stacking one top of the other, they got squeezed to 10 millimeters. Now the carpet is not going to fit there properly. It is not going to look right. And here you can see these dark lines. They look like dark lines, but what is happening? The carpet got squeezed. There is excess carpet there. There is air behind that. It's not sitting there properly. So people started looking into working with foams. Europe was already advanced in that area. They always used foam. They like to use foam. So this is the foam which you can pour properly. It will go behind the carpet, underneath the carpet. It will mold properly, so your fit would be perfect. Today, with the weight situation, with the energy situation, we are trying to reduce the weight. We are trying to reduce the weight not only on the body panels, but also on the sound package materials. If I can go from that barrier system to a fiber pad system, and if I can reduce the weight by about 30%, I've gotten some improvement in fuel economy. That is going to come also in electric vehicles. So this system is based on a 2 layers of fiber pad. One is more compressed and one is more lofty. That way, the dissipation, the energy dissipation is emphasized properly, and it can reduce the sound propagation more effectively. You will see that on the floor carpets. You will see that also on the dash mats. I'm going to now move on to the EVs and the AVs, the electric vehicles and the autonomous vehicles that are here, that will be coming. The EVs is coming because of the fuel economy, the energy crisis, and we want green other things. EVs are going to be more popular in my book because of China and few other countries. But then there will be AVs that will be there for us when we will not be able to drive our vehicles anymore, but we still want to be independent. So an autonomous vehicle would allow me to go from place A to place B without my driving the vehicle and so on. But what I wanted to mention, as we have EVs, the internal combustion engine is gone. It is all of a sudden a vacuum. Internal combustion engine, which made noise between 400 to 4,000 hertz, also masked, that means it hid a lot of sound which are related to low frequency wind noise or road noise. Now that that is gone, that road noise, the wind noise and some other ancillary device noises or buzz, squeak, and rattle at lower frequencies, they are becoming very prominent. Their magnitude may not be that high, but the frequency content is such that our ear can tell that. And we don't like it because that's not what we were listening to before. So that's one of the things that we need to understand. It is like draining the lake. This is the lake I have, and if I drain it, now I can see all the other things that are underneath that, and so on. We have tubeless tires for quite some time. And the moment we went to tubeless tires, between the rim and the tire, there is a cavity. In that cavity, there is a resonance. In that resonance, around 200 hertz. So it generates sound. In an internal combustion engine, that sound was there, but we never really paid much attention because of the other noises of the internal combustion engine. Now that we went to electric vehicles, where the electric motors noises are at higher frequencies, the inverter's noise at a higher frequency, that tire cavity noise is becoming important. Here you can see in the tire cavity, somebody has put in foam, which is an absorption material bonded to the inner part of the tire. Here you can see that foam. Some other car companies, some other suppliers, they are trying to see if we can have resonators so that that sound that is generated, that can be tuned through the perforation of these resonators so that it will mitigate that sound. So there are different ways of addressing that. But my point is that noise was there always the day we went to tubeless tires. But today that noise has become more important because of electric vehicles, because of luxury vehicles, than yesterday when most of the vehicles were internal combustion engine. Autonomous vehicles can change the entire architecture. It can change the entire internal design of the vehicle. Now somebody sitting in the car can relax, can do whatever they want to do, can have their business meeting. And when you have your business meeting and you like to have more glass, more openness, the noise from outside through the glass can come inside very easily. Glass has a positive thing, I can see through it, but glass also allows sound to come in at some specific frequencies more easily where our voices generate sound. So we have to be careful. Just because it is an electrically driven autonomous vehicle does not mean I don't have any noise issues. Of course, there are concerns of the safety because depending on the safety restraint systems, they need to be working properly. Now that I've changed the entire architecture, I want to make sure that I don't violate those restraint systems. If we go into the autonomous vehicles, there are three sensors: a camera, a radar, and a lidar. Camera, it can detect where the object is, can detect the color. However, if the weather is not good, it cannot work very well. If the lighting is not great, it may not be able to work very well. Its velocity estimation and distance estimation is not very good. The radar, which works on the detection system used by radio waves, it can identify the object, it can identify what distance away it is, the velocity detection, it can work in bad weather, it can detect the range. But the object classification may not be that great, the lane tracking may not be that great, and the angular resolution isn't that great. If we go to the LiDAR, which is the detection system which works on the principle of radar, but uses light as the lasers, then I have object detection very good, angular resolution is very good, but still the lane tracking, the operation in heavy rain or bad weather, those things are not that great. So what it is telling us here, for different sensors and fusion, camera has some areas it performs very well. The radar performs very well in many areas. LiDARs performs well in some areas. We can fuse some of these things, we can blend some of these things, and we can get the best of the best that may be necessary for this case. With that, this actually concludes my presentation, but I would like to see if I can play a video. If I have any trouble to stop. This is the ad for an autonomous vehicle. You can enjoy anything you want to drive. Okay. Now what did I do? Any questions?
Well, thank you, Dr. Shah. Very nice coverage of the subject. And very nicely presented, I must say. Not fast, not too slow. Coverage is very nice. And there must be some queries from audience. So it's now open to the floor. Any queries? Including those from our scholars or students? Even though I don't see many scholars here, but some are still there.
What happened? Vachudha, you started.
Yes, Achyuta, we can always start with you.
Then I'll follow up.
And it has become a tradition.
Yeah. Excellent tradition.
I know this is a different kind of presentation from what you
You
normally
are
are
still
having,
muted, Achyuta.
but with
Yeah.
Mahindra, Tata, and all the things that are happening in India, I'm sure that many of your students and young engineers, they would be working in the automotive industry and they would find some of this information would be beneficial if they're working in acoustics.
Yes, even in their professional lives and later on also, so they could draw more information from you, more expertise from you when they need. So in a way, we are bridging the gap between experts and the budding engineers. So whenever they need, they can draw more information and expertise. Yes, Achyuta, you have any comments to make?
Actually, I am overwhelmed by the
Yeah.
knowledge base and the presentation of Dr. Pranab Saha. That was beautiful. I mean, so much of information I am trying to grasp, and I am trying to absorb. I had no idea that in sound. I'll tell you once in West Germany I was visiting a gearbox manufacturer.
Oh, he got disconnected.
Achudha got, I think, some disturbance with his connection.
Yes, please. Anything wrong? Shall I continue?
Yes, please. I'm not
Yes.
sure whether the difficulty was with your connection or mine. Yes, please carry on.
Yes. So I had an idea of a noiseless room. I mean, that was very fascinating to me. But today, with Dr. Shah's presentation, I am doubly fascinated. And actually, the subject is no new to me, that I am overwhelmed. And I thank Dr. Pranab Saha for such a beautiful and clear presentation. That's all. Thank you very much.
Thank you, Achudha.
You're welcome. Uchudha, you can call me Pranab. You don't have to call me Dr. Pranab Saha.
No, why you have earned the doctorate in a very hard and tough way. So, yes, I can call you Pranab, but I can call you
Actually,
Dr.
all of you
Pranab
can
also.
call me by my first name, Pranab.
Yes,
Like
but you
Pranab,
earned your
following that.
doctorate. Pranab, you earned your doctorate after a very hard work. It is not an easy job. So, I can call you Dr. Pranab.
Thank you.
Okay, Pranab, following our B college tradition, this is Biman Ghosh, 81 Metallurgy. I just have a quick question. Most of your work that you presented, I see, like the research, the data collection, etc., is based on passenger cars. But what happens to the semis, the large trucks, where essentially people spend a larger chunk of their time who are driving those vehicles, sometimes 8-10 hours a day? And what is the magnitude of that noise, and how your research caters to the need of noise reduction in the larger vehicles? Thank you.
Very good question. Very interesting question. I cannot speak for exactly in the Indian trucking industry what's happening, but Volvo, who makes trucks, Scandia, who makes trucks, they put a lot of effort in reducing the noise inside the vehicle. And in the trucking industry, they are not too worried about lightweighting things. They are worried about the drivers, the operators' comfort. Okay, so they don't get tired. You may know that in today's trucks, they even have sleeping couch, so that when the driver gets tired, they can stop at a rest stop or wherever their stops are, truck stops, and they have a bed behind the seats where they can take rest. But another thing I want to mention, this autonomous vehicles, they are putting a lot of effort on these semi trucks so that the trucks can run to essentially 24 hours a day, and a live operator may be running only 8 hours a day. The other 16 hours or so, or 10 or 12 hours, if the autonomous thing, the truck can run by itself. So there's a lot of effort being done or work being done in that area.
Just a
I
related
think,
question, with
Dr. Pranab, that this autonomous thing is somewhat distant, no? Is it a viable option today, sir?
It will be there. I can assure you that. It will be there very likely within the next 10 years that you will be able to buy one. A car company called Tesla, they feel that through software, they can make it autonomous. Now, some crazy drivers, they try to run it autonomously and they get in trouble in accidents. I'm not suggesting anybody should do that. But what I'm saying, we may not feel comfortable as a passenger on an autonomous vehicle, but the car companies are working thoroughly, aggressively, and very diligently to make sure it can be as safe as possible. I did not show you a picture today, a horse-driven carriage. 100 years ago, when we had horse-driven carriage, from there, when we had automobiles, internal combustion engine automobiles, I'm sure people didn't feel comfortable at that point. But today, horse-driven carriages are not there. We all are very comfortable with automobiles. 30 years from now, we'll be more comfortable with autonomous vehicles than what we are today.
Thank you. Thank you.
Just one follow-up question, Pranab, before I end. With the advent of all these sensing technologies, like sometimes the trucks probably make more noise while stopping, the braking noises, their air escaping after the braking from the air operated actuators and all that. How much do you think is our contribution to the advent of technologies that is bringing up all the associated noise makers that is there in a large vehicles like a truck or a semi?
I think they are very critical. With new things, new gadgets, and whether it's safety or something else, you have other nuisances also that have to be addressed in some fashion.
Thank you very much. Like Uchud, I am also overwhelmed and excited to learn more from you. Thank you. By the way, Dada, where do you live in US?
I live in the Detroit area in
Okay.
Michigan.
Okay, I was there yesterday. Next time, probably I'll stop by. Thank you.
Our
Sure.
friend Dr. Jyotsnamoy Chakraborty lives there in the Detroit area.
We could not get
61 batch. Dr. Jyotsnamoy Chakraborty.
we could not hear his lecture on gears. Missed him.
Yeah, we missed him. Yeah, he did not agree.
I'll look for him in some other forum. Yes,
Pramod,
Can you hear me?
Yeah, I can hear you. Okay.
Yeah, this is Pranab's brother, elder brother, Pradeep. It was very interesting. Obviously, I have visited his company and they have this anechoic chamber and things like that. It was very interesting. I have a question regarding, first of all, electric vehicle, because we are not transitioning to electric vehicle yet. There are a lot of issues, although Tesla would like all of us to buy one. But there are other issues, even with electric vehicle, not enough charging station, particularly at home and things like that. And feel of I have not driven, I do not own an electric vehicle because I don't feel that my wife will be comfortable with it. And with our advanced age, naturally, we are reluctant to switch to other type of vehicle at this time. So given that this automotive or AV seems to be at a further distance, and I will be very, very reluctant to be in an AV because, okay, 1 month ago, we were talking about nuclear power, even though we try to make it as safe as possible, since it is the human-made things, as Ochuda had pointed out. Yeah, there could be some accident, the probability of making accident zero is impossible. Same thing with the vehicle. So I would rather, I do not even use cruise control, really. I know I have cruise control in my car, but I don't use it. I want to be alert and and there are still a lot of crazy drivers in USA and I'm sure in many other countries. They do not want to follow the rules. They do not put the blinkers or indicators when they change lanes, things like that. So I am always very careful about the other drivers also around. So with all this thing, AV, at least not in my lifetime, maybe 50 years from today, but I won't be here. So I'm glad that Pranab gave a very good lecture and and he has covered everything, and I congratulate him for that. Not just because he's my brother, but as a technical person also, he is doing very well. And just thanks to all of you.
Thank you, Dada.
Thank you.
Thank you. Okay, let me, Pranab, I agree with everybody. Frankly speaking, it's a very difficult topic, acoustic. And I still remember when I was starting in the undergraduate level, vibration was not one of my favorite cup of tea. And it is way beyond that. So you did a wonderful job and going through early days to what is coming. It's really very interesting. And by the way, okay, let's not. I have a question for you, really. The way I'm looking at it, your presentation, without knowing anything about it, but a hunch is that what we basically presented, if I make it simple as an engineer, draw a block diagram, here's my source of noise, and then I have a system or material that will try to dampen it so that my output will be reduced noise. That's the big picture, so that I can see it.
Correct.
Here's my question. My question is that after hearing everything you said, looks like it is to me is a passive system. In the block diagram, this material does nothing but whatever it is destined to do it or designed to do it, that's it. My question is that what is the future coming in terms of active damping, in terms of smart material, in terms of artificial intelligence, where they will hear the noise, understand the behavior, and understand the environment and be responsive. Just to give an example, I have got 200 plus channels in my TV, right? But my TV, when it turns on, it immediately knows which one I want. Okay? If it doesn't like it, then switch to another one. So it gives me guidance. So it is not ideal, but using of smart material and artificial intelligence, basically, can I give, at least in theory, I think I can give that positive feedback and rearrange or realign my material so that it will be more responsive. Does it make sense?
Yes. Today, what I talked, everything is passive, correct. But active noise cancellation is very much there. It's not only in the headphones that we wear active noise cancellation. The car companies have been working on that very diligently for the last 30 years or so. They know how to do it. Some of the OEMs are not that sure that people will bear the expenses for that, or people would like the idea of that. But there is active noise cancellation application on the exhaust for internal combustion engines, as well as through the headliners and the sound system inside the vehicle. It can do the active noise cancellation work for the vehicle interior. My understanding is Nissan or maybe Honda had active vibration cancellation in the engine compartment for 5 or 6 years. And today, one of the car companies, they have it, but I don't know exactly which one. It will be coming. I mean, people have been working for 30 years. I have seen 30 years ago somebody's OEM's entire trunk, that means the back area, was full of electronics. Today, those things can be minimized into a much smaller volume in a shoebox or something like that. And someday, passive materials these barriers, absorbers, and active sensors, they will blend together and try to address both the low frequencies and the high frequencies. And it is coming.
Thank you. I think cost should not be an issue in the sense that it is always, we already have Mercedes, we already have Lexus, we already have Malibu. We know our customer base. I know who wants to who is willing to pay what. So accordingly, you are absolutely right. Not every vehicle will have it, but definitely some of the high-end vehicles will definitely have it, and it will seep into the Lexus areas too. So adjustment. Another quick question on a totally different area. Is there any application of nanomaterials in the noise or in the acoustic designs or not yet?
No, people are looking into that. For example, when I talk about fibers, at one time we used to use cotton fibers. Cotton fibers could be like the denim, jeans, and other things. You know, those fibers, if you look at them, they're a little thicker than polypropylene or polyester fibers. They're much finer fibers. So people who are working with polypropylene and polyester fibers, they are also working with nanofiber materials to see how they can improve the performance without increasing the weight. And I know we have a lot of different people in this group. So if I say North Carolina or South Carolina, it doesn't mean a lot of things to a lot of people, but in every country, they are trying to work in some fashion with nanomaterials.
Thank you. Thank you. I just want to make sure. Okay. May I ask one last question?
Yeah, I have no problem.
Now I'm talking another totally different area. I'm talking about supersonic booms or supersonic carriers. Okay. Now I understand that they are also working on to work around the booming effect using different design and materials. Can you shed any light on it?
No, I cannot because I don't know much about that. I know the work is being done, but I'm not really the person to talk about that.
Okay. Thank you one more time, Pranab. You did a wonderful job. It's a really difficult subject, really difficult. You did a wonderful. Thank you.
I do have something I wanted to share with Vidyut and Shudeep. I know your students possibly are attending this, but they have not asked any questions. I can understand that. Separately, once we are done, you can ask them how did they like it, if they have any questions, if they are interested, whether through your student group or some other group, I can come back and make presentations that can be more technically oriented. That might help.
Even teachers too. Teachers from our department are also welcome to ask questions if there are some. I have a query, Pranab, if you can say. When it comes to absorbing materials, sound absorbers, should we say that it's the high frequency sound which is difficult to absorb, or it's all about amplitude?
Did you say 5 to 10 feet sound?
I was saying, is it that high frequency sound is difficult to absorb?
High frequency sound. No, actually, high frequency sound would be more easy to absorb.
Achha. So it's reverse.
Okay.
So it depends on
It's the
amplitude.
low frequency is the problem. And you have to understand it's not always the materials problem, it's the application. If you can put a 1 meter thick material, it can absorb even at 100 hertz. But you only have room to put 25 millimeter thick sample. And therefore, that space becomes important. But typically, materials perform well at higher frequencies.
You are talking about jute based some jute based carpet panel or
Yes.
something like that. We have seen similar things made from straw. If you remember,
Yes.
sometime we used to put on auditorium walls some resin bonded straw panels.
Yep.
So these straw panels, they are basically acting as absorber, where we
Yes.
do not really need absorber in hall. We rather need diffuser, as we were mentioning initially. So
Well, it
was that the wrong
depends
way of putting
how
it?
it depends how we define the word diffuser. Okay, but there are two special test rooms. One room recreates the outdoor environment, which is an anechoic or an hemianechoic room, where ane means snow, coic means reflection. In a room like that, you do need absorbers.
Achha.
Another room, and in a room like that, you test the engine, you test the noise source. But there is another room, which we call is a reverberation room, where the sound bounces back and forth, hitting the walls and surfaces, and become uniform in that room. In a room like that, you do not need absorbers. You need more
Diffusers.
hard surfaces, and yes, we call diffusers, which are there to reflect the sound and diffuse the sound waves. In a room like that, you measure those passive materials, those absorbers, barriers, and other materials to know their performance. There is another thing sometimes in a room where you are doing listening. Okay, listening means those tape recorded signals, they are played through the loudspeakers, and you are the juror, you are judging the quality of the sound. In a room like that, you don't want the room to be purely absorptive, neither do you want the room to be reflective. So, a lot of times people will use, I want to say the word diffusers, but which are essentially tuning up the sound at certain frequencies.
Right.
Okay.
And
Okay.
one more thing, in automobile application, the seat covers that we use, this plastic or nylon, do they also have absorbing quality? I mean, do they absorb sound to some extent? Because nylon, we are told it's also an absorber.
Actually, I'm going to share with you two things. That absorption material that we said, on top of that, if you put a liner, that liner could be one of two types. One type of liner, we call it a film. That means you cannot blow air through it. That is the nylon cover that you are talking in the seats, or vinyl or leather, whatever you call it. It does not allow the sound to go into the cushion of the seats. That does not help absorbing sound much at high frequencies. That's a bad thing. But somebody who is paying a lot of money for that seat also expects it to be absorptive. There are perforations in those seats.
Oh, yes. It's
You
perforated
don't
seat
like
for
the
that.
perforations, you don't like to see those holes. Nowadays, they have micro perforation. So it does its acoustic work, but you don't see it.
Right.
There is another type of liner, which we call it a scrim, that you can blow air through it. And when you blow air through it, that allows the sound to go through. And that scream is designed so that it can enhance the acoustic performance. It will have higher absorption performance.
Thank you. Now I know why there are perforations on seat covers.
Well, I hope I helped rather than confusing,
Okay.
the issue.
Well, any more queries from the audience? I was asking a lot of questions.
No, thank you from my side. Thank you, Pranab. Vidyut, I have to go, Sudeep.
Well,
But it was wonderful. I actually delayed my appointment by half an hour just for you. It was so exciting. Okay, thank
Thanks
you.
for the opportunity. I really
on
like
behalf
it.
of the
Thanks.
department and on behalf of the Centenary Celebration Committee, also let me thank Pranab for this wonderful lecture. We enjoyed a lot together with so many senior members of alumni coming together to hear this lecture. Thank you. Thank you very much. I have a short responsibility to do. We have a certificate from Centenary Celebration Committee. The digital copy is displayed here, which we'll be sending to Pranab through email. The hard copy along with a memento will be preserving with us for handing over sometime or arranging to deliver to your doorstep somehow, someday. Don't mind if we delay.
Thank you so much.
So we'll be doing that. And thank you very much. We are honored to hand this certificate to you. Thank you. Yes, this is this image of the memento we have for Centenary
Thank you.
Celebration.
Thank you.
Thanks a lot,
Okay.
Pranab.